Lesson 8.2, Two-Variable Linear Systems. If we have a two-variable linear system which graphs two lines, we have three possibilities for solutions. First one is the two lines intersect at one point. So there's one solution, and we call this consistent, which means there's at least one solution, and independent, meaning there's just the one solution. The value of y in the solution is independent of the value of x in the solution. Or they could graph the same line. So there's infinitely many solutions. Every point on the line is a solution. This is called consistent, meaning there's at least one solution, and dependent. The value of y in the solution depends on the value of x in the solution. Or you could have parallel lines. Parallel lines never intersect, so there is no solution. And this is called inconsistent. We could solve two-variable linear systems using graphing, but sometimes if we don't graph super neatly, it may be hard to figure out the answer. Or by using substitution, which works just fine. Or maybe a nicer method that works for linear systems is elimination. To solve by elimination, you write your equations in columns, so you have your x's, your y's, equals the constants. And then you obtain coefficients of one of the variables that differ only in sign by multiplying the equations by constants. So you can multiply one or both equations by numbers so that you end up with the same coefficient but opposite sign on one of the variables. So you have like 2x and negative 2x, or 5y and negative 5y. Then you can add the equations because both sides are equal. So we're adding the same value to both sides. We're adding the equations, which will eliminate one of the variables. So you can solve the resulting equation. And that gives you one of the variable answers. So you can substitute that answer into either of the original equations and solve for the other variable. And of course, you should always check your solutions. When you're solving and all the variables are eliminated, and you get a true statement like 0 equals 0, then you know you have infinitely many solutions and they graph the same line. But if all the variables are eliminated and you get a false statement like 0 equals 9, it tells you the lines are parallel and there are no solutions. So let's solve this system of equations by elimination. They're linear equations, there's no squareds. We need to multiply the equations by something so we get the same coefficient but opposite sign on a variable. So we could multiply this first equation by 3, and that would give us 3y on top and negative 3y on the bottom one. So if we multiply by 3, we'll have 12x plus 3y equals negative 9. At the bottom, I'm not multiplying by anything. So now that we have 3y and negative 3y, so then we add. Students always ask, can I just set it up to subtract? Technically, yes. However, I have students who then will go halfway through subtracting and then switch to adding or subtracting. So I always set it up to add. That way, you never forget what you're doing. So we'll get 13x, no y's, and 0. That means there's no solution, right? Oh no, there's a solution. X is 0. That is a solution. So then we can plug that into one of our original equations. 4 times x plus y equals negative 3. So y is negative 3, and our answer is 0, negative 3. Shall we see that that works by graphing? If I take my first equation and solve it for y, start at -3, go down 4 over 1, or up 4, backwards 1. The other equation, if I solve it for y, we'll subtract the x first, and then divide by -3. So it'll be 1/3 x minus 3. So we start at -3, go up 1 over 3. And you can see they intersect right there at 0, -3. It works.